Hi students, in this video I'll be recapping some concepts about quadratic functions as well as completing the square, and then after that I'll be doing one example on completing the square. And in the description below you will find a link to the 2023 O-Level A Math paper 1 question 12, okay, whereby we will get to apply the concepts that we have discussed. Alright, so let's start off by talking about the quadratic function. Okay, so in this particular video, I want to focus on quadratic functions of this form. So y equals to ax minus or ax plus b squared plus c form. Okay, so quadratic functions of this form, a times x plus b squared plus c form. Right? Okay, so let's use one particular example. So let's say we have this question. Right, so we have this particular equation. Okay, so we want to sketch this particular quadratic function out. All right. Okay, so the first thing that you need to observe for quadratic function is you got to look at this value of a over here. Okay, so the value of a is a positive 2. So if it's a positive 2, basically what it tells us is it tells us the shape of the graph. So if it's a positive number, then it will be what we call a smiley face. So the shape of the graph will look like this. All right. Okay, then the next thing will be to find what is the coordinates of this turning point on the graph. So in this case, it's a minimum point, the lowest point on the graph, right? Okay, so the advantage of expressing a quadratic function in this form, right, is that we will be able to tell what is the coordinates of the minimum point very easily. Right, so the idea behind this is why can we tell so easily is this? Okay, the focus will be on this particular squared term. Okay, so we all know that a squared term is or either is positive or is equals to 0. Okay, so it's always greater or equals to 0. It will be 0 when x is equals to 3. Then we will have 3 minus 3 squared equals to 0. Any other x value you sub in, okay, whether x minus 3 is positive or negative, when you square it, it will eventually become positive. Okay, that's why we can say that x minus 3 squared is greater or equals to 0. Okay, so it doesn't matter. Okay, in front here we have a 2, right? So even if you add 2 in front, so you times 2 on both sides, on the right side is still 2 times 0, it will still be greater or equals to 0. Alright, so now if let's say we add a 5 behind, right? So recall that in math, if you add something on the left side, you need to do the same thing on the right side. So the right side will be 0 plus 5, which will be 5. Okay, this means that this particular expression, okay, this expression is actually y, right? Okay, so this means that y is greater or equals to 5. That means the smallest value of y will be 5, right? Agree or not? Because y is greater or equal to 5. It's either 5 or bigger. Okay, so this allows us to know what is the y coordinate, right? Okay, of the lowest point. Okay, since y, the smallest value we can take is 5. Alright? Okay, so when will y be 5? Okay, y will be 5 when this whole thing inside here is equal to 0. Correct or not? Because basically the whole expression is this term plus 5. Okay, so in order to get 5, this term, right, the 2 times x minus 3 squared has got to be equal to 0. Then we have 0 plus 5, then we get 5. Okay, so when will this term be 0? When x is equal to 3. Because when x is equal to 3, we will have 2 times 3 minus 3 squared, which is equal to 0. So this tells us the x coordinate of the minimum point. Okay, when x is 3, y will be 5. So this is the advantage of expressing a quadratic function in this form. It allows us to tell the minimum point very easily. Okay, so then we can use this to sketch the graph already, because we will have a case like this. Okay, so the minimum point is at 3, 5. So let's say 3 is here. Okay, then 5 is somewhere here. Okay, then the minimum point will be at 3, 5. So this will be the minimum point. Okay, so this is 3, 5. Okay, so we know that it's a smiley face, so it's going to curve outwards this way. Okay, so the only thing that we want to now ascertain is where will the graph cut the y-axis? Okay, if it's going to cut the y-axis at, let's say, like 7, then it's going to be something like this, okay, like this shape, very broad one. Okay, but if it's going to cut somewhere higher up, then it may become more narrow like this. Okay, so this is what we want to ascertain. Okay, so it's very easy to determine the y-intercept also. Remember, at the y-intercept, at the y-axis, right, what is the coordinate of x? Coordinate of x will be 0, right? Okay, so what we can do is we can sub x equals to 0 inside the equation and find what is the y. So in this case, we will get this. Okay, so this will be 2 times negative 3 square will be 9 plus 5, so 18 plus 5. So for this graph is rather high at 23. Okay, but my way of drawing is I will usually just, I know it's somewhere quite high up, I will draw first, then after that then I will mark the point. Okay, because you don't have to be so precise. Okay, so it's very hard for me to draw a nice graph using this tablet. Okay, but let's try. Okay, so I think I will draw from the top, easier. Okay, so it will come down this way. Okay, so this should be curved, and then it will go back up this way. Right, so I draw first, then I mark this as the 23. Okay, so this is how the quadratic graph will look like. Right. Okay, let's try one where a is negative. Okay, so we try one where a is negative. Okay, so let's label the axis first. Okay, so let's say we have y equals to now negative 2 instead. Okay, so when a is negative, so this is the a value. So if a is negative, then it will be a set phase graph, right? Okay, so a set phase graph will have a maximum point. So going by the same argument, okay, so okay, let's do the inequality thing again. So this will be greater or equal to 0, right? So now I'm going to add a minus 2 in front. Okay, so remember when you multiply an inequality by a negative number, you need to flip the sign, reverse the sign. Okay, then now you have a plus 5 behind, right? Okay, so when you add 5 on the left side, you need to add 5 on the right side. So what can we see now? This whole thing, which is y, is now less than or equal to 5. That means it's either equal to 5 or less than 5, which means that now the coordinate of the maximum point will be 5. So you should realize that now the y coordinate of the turning point, right, whether it's maximum or minimum, will just be the number behind. Right, so when will this thing be 5? When will y be 5? When now when we want to make this one equal to 0, okay, then we will have 0 plus 5, then we get 5, the maximum point. Okay, so when will this thing be 0? Again, we want to focus on the squared term. Okay, when will the squared term be 0? When x is negative 1, right? Because if it's negative 1, then we will have this. Negative 1 plus 1 will get 0 squared, then we will get 0. Okay, so now we will be able to tell, okay, what is the coordinate of the x coordinate of the maximum point, right? Okay, then let's sketch. Okay, so it's very close to the y-axis, so it's a negative 1. Okay, and then we have at 5. Okay, so it will be over here, negative 1, 5. Right, so once again, we want to know whether it's narrow or more broad. Okay, so we need to know the y-intercept. So at the y-intercept, x will be 0. So what we'll do is x equal to 0, just sub in x0 into the equation. Okay, so over here you have 1 square, which will be 1 plus 5. So minus 2 plus 5, you get 3. So this one is very near over here, somewhere here. Okay. Okay, so this one will look maybe something like this. Okay, now this way. Okay, then this one will turn over here. Okay, so we try to make it symmetrical. Okay, so mine is not 100% symmetrical. Okay, so something like this, right? Okay, so this is how you sketch the quadratic graph when it's given in the completed the square form, right? Okay, so now I will do one example of completing the square, right? Right, so let's say we want to express, okay, I'll do a more complicated one. Okay, express this one, okay, so express this particular a quadratic function in this form, a x minus h square plus k. Okay, in this case they want this form, okay, from this question. Okay, so to complete the square, what we want to do is we always want to factorize out the first step, factorize out the coefficient of x squared. Okay, so the coefficient of x squared here is negative 1 over 20. So the step is always to bring it out, okay, so that the coefficient of x squared becomes a positive. All right, positive 1. Okay, then the next question to ask yourself, negative 1 over 20 times what? Times what x, right, will become 2x. So that's the question we want to ask ourselves. Okay, so you should realize that it's going to be negative 40. Okay, so you try negative 40 times negative 1 over 20 will become negative, the negative become positive. So it's correct. Then 40 over 20 gives you the 2. Okay, then ask yourself the same question. Negative 1 over 20 times what will give you a positive 1. Okay, so it should be quite obvious that it's a negative 20. Okay, negative 20 times negative 1 over 20 become positive 1. Okay, so you should always expand back and see whether you got the expression in the previous step. Then you will know whether you have done it correctly or not. Okay, so now that we have made the coefficient of x squared 1, we can complete the square already. Okay, so to complete the square is very easy also. Okay, what we need to do for the first step is to add the square of half of this number. So half of negative 40 is negative 20, right? So we'll add the square of this. All right. Okay, so if we have added something into the question, we've got to do something about it, because now the question, the value of the expression is different already. Okay, so what we'll do is we'll just multiply, subtract it away. All right, subtract away. Then the negative 20 still remains. Okay, so this one from here. Okay, so what we have added to this step is this negative 20 square minus negative 20 square. So essentially this one is actually 0, right? So we have not changed anything to the value of the expression. Okay, but why do we want to do so? It's because these three terms, okay, these three terms these three terms will now factorize to just this. Okay, so you actually can go and expand this one out and see for yourself. Okay, if you expand this one, okay, x squared, okay, minus 20x minus 20x, then minus 20 times minus 20 is already in this form. Okay, so you get, okay, there's a square here. Okay, x squared minus 40x plus negative 20 squared, which is this thing one. Okay, these two are equal. All right, these two are equal. Okay, then there's one more thing to do here. Okay, which is just to group all this one together. So this one you can actually just use your calculator. So negative 20 squared is 400. So negative 400 minus another 20, that will give you negative 420. Alright. Okay, then from here we just multiply this one back in, multiply this one back in. Okay, so you'll get negative 1 over 20 x minus 20 square. Okay, then negative 1 over 20 times negative 420, you will get positive 21. Okay, so in this case, you can see that for the expression that they want us to express in, so in this case, a will be equals to negative 1 over 20, then h will be 20, and then k will be 21. Alright, so this is how you do completing the square. Okay, so this one requires some practice. Okay, so you should take out a few questions, whether is it in your FLAIR or in the TYS, and then you practice for yourself. Okay, so as mentioned, in the description, okay, there will be a link to the 2023 paper 1 question 12. So it's a full question, a 10-mark question on quadratic functions that requires the use of completing the square, as well as to identify the maximum value of a quadratic function once you have it in the completed the square form. All right, then of course there's some other questions also related. Okay, so do click the link at video as well. Okay, but before I watch that video, you should try the question first. Okay, so the question will be shown in the video itself. Okay, so before you see my solution, you pause the video and you try the question on your own first. All right. Okay, so